Carbon dioxide is a gas you've probably already heard of. Most people know its formula as CO2, which means in a molecule of carbon dioxide you have one carbon and two oxygens. You have to know some facts about carbon dioxide, including its uses and also how to make it in the laboratory. There are two methods you need to know about. One of them is thermal decomposition and the other one is the reaction of a carbonate with acid. You can generate pure carbon dioxide in the lab by reacting a carbonate with a dilute acid. You can react any carbonate, for example copper carbonate or calcium carbonate, with any dilute acid you like, but the most common one we use is hydrochloric acid. Pure carbon dioxide can be made by adding a dilute acid to metal carbonates. Dilute acids react with metal carbonates to form a salt of the acid, carbon dioxide and water, and we can collect that carbon dioxide through a delivery tube either via downward delivery or collection over water. When I add the acid to the carbonate, I've got two carbonates here to show you, copper carbonate here which is green and calcium carbonate in the form of marble chips which are white. When I add the acid you can see that the reaction fizzes, which is the carbon dioxide coming off, and you can probably hear it as well. With copper carbonate you may see it go slightly blue because the copper chloride dissolved in the water is blue. The calcium carbonate fizzes as well. Now we can get this to turn lime water cloudy, which is the test for carbon dioxide, if I connect a delivery tube to the top and I bubble the carbon dioxide through the lime water on that side. We can test the carbon dioxide by bubbling it through lime water using a delivery tube. Add a little bit more acid to make it fizz. There you go. You can see the bubbles of carbon dioxide gas going through the delivery tube here, and you can see very quickly that the lime water turns cloudy or milky. That's because you're getting a solid precipitate of calcium carbonate forming in the lime water. And that's because the calcium hydroxide in the lime water is reacting with the carbon dioxide gas going through it. The lime water turns milky because you get a solid precipitate of calcium carbonate forming in the water as the calcium hydroxide of the lime water reacts with the carbon dioxide gas. So here is the lime water reaction that you've just seen. Calcium hydroxide dissolved in water reacts with the carbon dioxide we were bubbling through it. This forms the solid precipitate which is white of calcium carbonate, and that's what made the lime water turn milky or cloudy. And we also made water, which you wouldn't have seen because it would have dissolved in with the rest of the lime water. Another way of making carbon dioxide in the laboratory is by thermally decomposing metal carbonates. A good one to choose is copper 2 carbonate because it decomposes into a black powder. That way you can see the reaction has finished. This apparatus allows us to thermally decompose copper 2 carbonate quite easily. At one end we have the copper carbonate in a test tube connected to a delivery tube which will deliver the copper carbonate down into the lime water at the other end. Now when you're heating with a Bunsen burner you can hold the base and keep it moving over the base of the test tube. The copper carbonate gets hotter. It starts to thermally decompose into the black powder copper oxide and the carbon dioxide gas is generated. It starts to travel up the test tube, down the delivery tube and into lime water. As the carbon dioxide travels through the lime water, it reacts with the calcium hydroxide, giving us that cloudy white precipitate, making it look cloudy in appearance. Now when you stop heating your experiment, make sure to take it out fairly promptly from the lime water so you don't get suck back. And there you have it, thermal decomposition of copper 2 carbonate. And that's the way we make pure carbon dioxide in the laboratory, reacting a carbonate with an acid or thermal decomposition of copper 2 carbonate. Now let's look at some of the uses and relate them to their properties. Fires need oxygen to burn. Carbon dioxide does not support combustion and is denser than air, and that's why we use it in fire extinguishers. Carbon dioxide dissolves in water, so it makes it ideal to use in fizzy or what we call carbonated drinks. We keep the gas under pressure to put extra carbon dioxide in the drink until you release the cap, and that's what gives you those lovely bubbles. So carbon dioxide is a gas at temperature and is denser than air. You can make it in the laboratory by reacting a metal carbonate with hydrochloric acid or thermally decomposing copper-2 carbonate to make carbon dioxide gas. You test for that gas using lime water, which turns cloudy. That was the episode on carbon dioxide gas. You can click the link or scan the QR code now to be taken straight to your notes.